So good morning once again. Today we're going to continue our discussion on multiple linear regression. Last time we used these packages, Site, Pastex, OLSRR, Stargazer, and Skim. Of these, we haven't used actually yung OLSRR, which hopefully we'll be able to use today. We used the wage dataset, and I hope you have already loaded this. And we learned how to do some descriptive analysis in using R. We learned how to use the structure, the summary functions, and then check the type of data. Okay, we said that we can use the attach function. If we attach this, then we're signaling to R that the from that point down, we are referring to any variable from the wage data set, so that you don't need anymore to identify that a particular variable belongs to wage. Okay, so if you're going to use another data set, another object, okay, you have to detach this. Okay, you can detach this so that it won't create confusion. Okay, so we looked at descriptive statistics, and then we also learned how to plot using the plot function from the base R. In this plot, let me just quickly do this. Okay, so this is the scatter plot. Here, the education is on the x-axis. The first variable that you're defining here in the plot function is your x-axis, and then the y-axis. As you can see here, this is a scatter plot, and we're plotting the hourly wage as a. We'd like to see if it can be described, or if there's a relationship between hourly wage and education, which actually we did last time. Okay, and we can add more details to our plot. Here we're adding the label X label on the x-axis and label on the y-axis. And then we said that there are you can choose among the several plot characters. Okay, 20 is a small circle, black circle. Okay, so if we plot this, okay, so you have now your label on the y-axis, label on the x-axis, and then the plot character that we're using here is small black circles, as compared to this one, which is the default. I think this is plot character 19, which is the default. Okay, so R has a lot of very powerful data visualization tools. Okay, in the package ggplot2. So I'd like to encourage you to learn. There are many tutorials on ggplot2, the package. Okay, here, since we would like to establish a relationship between education and hourly wage, we want them to have very high correlation. Okay, so we're getting 0.406. It's just a medium, not really a strong correlation. Okay. There are statisticians that say that strong correlations start from 0.7 up, but there's no really established or standard let's say classification for that. Okay. And then here we can use the round function. Okay. The round function will put the decimal places. Okay, so here it's round 3, and then we're correlating from the wage function. We did this 4 to 6. Okay, why is that so? If we check the wage data set, okay, here we have 4 to 6. The columns 4 to 6, the variables 4 to 6 are character. So we can get the correlation of this. It will give us an error term if we try to get the correlation. So what we did here was to Oops, bakit nag-restart? Okay. Let me pause share first. Pause recording. Okay, so by way of review, let's look at what we did last time. So what we did last time was to create a model. We named it Model 1. And then we're assigning Model 1 to the output for the linear model. So we said that to do linear regression in R, we use the LM function. And we identify first the dependent variable, which in our case is hourly wage. And then we use the tilde, okay, the tilde symbol to define that hourly wage will be regressed on education, okay? And the data that we're using is the wage data, okay? So this is the simple function for to create an object called mod1, which is a simple linear regression model for where we are regressing hourly wage on education. Now, if we put this in parentheses, we didn't do this last time. It will give us a summary of the output. Control Enter. There, it will just give us the result, the intercept and the education. Okay, but it's not a complete output. If we want to know more about mod 1, you can take a look at this one here, mod 1. If I click this, then it will give us what are the contents of mod 1. It's a list. It contains the coefficients. These are the two coefficients, negative 9.05 and 0.54, which we discussed last time. Also the residuals, then the effects, then the fitted values, okay, and some other uh, elements that we can find in mod 1. Okay. All right, so where's our, here. Let me put this here, okay? And we can identify what are the elements of mod 1 by using the names function here, names function, control enter. And these are the elements of your mod 1 object, your regression output. So as I mentioned a while ago, you will have there the coefficients, the residuals, the effects. And you can actually have that printed, for example, mod 1 and then $sign. If I put dollar, then it will identify what are the elements of your mod 1 object. So for example, if I click coefficients, control enter, it will print to us the what's inside coefficients. So mod 1, it's mod 1 and then $sign. Okay, so we have here several objects. Okay, the residuals are, as we discussed last time, the error terms. If I click this model, okay, so it will give us the your dependent variable hourly wage and your independent variable education, right? So you can explore what are the elements inside your mod 1. The residuals will give us the printout of all the error terms, okay? The difference between your actual value and your predicted value. Let's see if we can round this round and make it just 2 decimal places. Let me see. I'm not sure if we can. Let's see. Yeah, we can. Yeah. So it just rounds the results to 2 decimal places. Okay. So we can we learned also last time how to plot the regression line. So I'm sorry, I lost my our plot here. Okay, so let me just plot this once again. Plot. So we're plotting wage. Or on the x-axis you have education, and then on the y-axis wage dollar hourly wage, right? And what we did was to label your x-axis, x label as years of education, quotations, and then our y lab is equal to hourly wage, okay? And we can give a label to the main plot is scatter plot of education and hourly wage. And then we can define the plot character. We used 20, right? What else? Okay. And actually we can use the frame function. Okay, if we use frame function true, it will put a frame to it. If we use false, then it will not. Let's just experiment on that. All right, then we can AB line. We did this last time. Just a quick review. AB line, then we'd like to put the regression line on the hourly wage, regressed on education. Okay. Okay, we have to close this. And then we can color, let's make it red. For red, for the color, we have to, okay, 1, 2, we close this, okay, 1, 2, so only one. All right, so this is the code that we use for plotting. Okay, so you will have two plots here. One is the scatter plot for education and hourly wage, and the other is the regression line. Sorry, hourly wage, education. Okay, let's see. Let's run this code chunk. Okay, I'm locking here. I forgot to put here data is equal to wage. Okay. All right. So this is our scatter plot, and R gives us the regression line. Okay, this is our ordinary least squares line. Okay, the points here on the line are your predicted values. Okay, these are your actual values, the black dots, and the difference between, for example, at this point, the difference, let me annotate this. Okay, so this is one actual point, and for this specific hourly wage, any point here consists of your X and Y, right? X, which is your education, and Y is your hourly wage. So this point represents the value of your X and your Y. And then at this point, this is the predicted value, okay, given this. Okay, how do you predict, guys? Remember, we have this equation, our Y, our hourly wage is equal to, what are the intercepts? Negative 0.9 something. Let me first. Kindly, guys, what's your negative 0.90, right? Your intercept, negative 0.9 something plus point, was it 0.54? 0.54 x. Okay, so how do we compute for the predicted value of y? Okay, if we know x, we substitute it to this equation. Okay, so for that corresponding x value, we have your predicted y. Okay, but we know the actual value. Yeah, thank you, James. No, negative. I think this is negative 0.904, and this is negative. This is positive 0.54. So that's our regression line, right? So we use the regression line in order to compute for the predicted values, okay, or the fitted values. So for example, where's our range here? Okay. I have to clear this. Okay. Okay. So let's say for this one, for observation number 5, your education is 12. You can now use this 12 years of education in order to predict the value of your hourly wage. How do you predict that? You use the equation. This negative 0.904 plus 0.54 times x. You substitute, you multiply 0.54 times your x, which is 12. And then you perform that operation, 0.904 plus 0.54 times 12, to get your predicted value of your hourly wage. Okay, and then you compare it with 5.3, okay, which is the actual. So for this observation, you have 12 years of education, and the actual hourly wage is 5.4, 5.3. So you can compute for the predicted value, and once you're able to compute for the predicted value, you can now compute for the residual. The difference between your actual value 5.3 and the predicted value, how do you get the predicted value? Using the equation, 0.904 plus 0.54 times x. You substitute x with 12. Therefore, you can compute for the predicted value. The value that you're getting when you perform, when you use it for your regression line, is your fitted value or your predicted value. Okay? Let me pause for a while. Is that clear, guys, yung concept ng actual value? The actual value are your observed value. These are the given values. These are the values that were generated by to the survey. Okay? And then we used your also your observed value for your education and your hourly wage to come up with this regression model. So with this linear regression model, you'll be able to predict the value of your hourly wage. Predict, or you'll be able to get the fitted value. Okay. So let me pause for a while. Is that clear, class? Paki-chat down, please. If that the concept of comparing your actual value with your fitted value to get the residual value. Kindly chat, please, if it's yes. Okay, good. Thank you. All right. So that was just a review of what we have done so far. So let's now move on. Okay, thank you for the feedback. Okay, let's now move on, class. Now, for this one, we will first hold this. We will suspend our discussion first on residuals. We will discuss residuals when we go to the final model. So let's keep that for a while. Okay, and let's go here. Okay. Now I think what I gave you does not have this, right? Okay. So I'm using a different file. All right. So let's now move on to multiple linear regression. Okay, I think for, okay, let me see. I'm sorry, guys, I lost the file a while ago. All right, let's first take a look at our wage data set again. So where's that? Here. Okay, so this is our wage data set. Now, what we started was a simple linear regression because we were regressing hourly wage on education. Now what we're going to do is a multiple linear regression where we use all the variables, okay, all the variables to regress hourly wage on. Okay, so hourly wage will be regressed on education, experience, tenure, and even race, gender, and civil status. Okay, so it's very important to understand that we can do linear regression. Okay, we can do linear regression using character variables. Okay, so let's try first. Let's try first. Okay, so let's do this. Okay, we're creating now module 2. May I know, guys, if you have this? You don't have it, right? What's yes? You have the code or no? Ah, you have it. Okay. I failed to remove it. I failed to remove it. I should have removed it, class, because I want you to be doing the code yourself. But first, let's go back a bit. Let's backtrack a bit and remember the correlation that we did. Okay, so let's correlate the wage. We can use the core function to correlate the variables in your wage function. However, we have to subset it because we cannot correlate your character variables. We don't have any correlation with character variables. So what we do, this bracket is your subset, and then we will leave this blank, which means this is the row. So we include all the rows, but for the columns, okay, we have to put a negative C, which means it will combine but not include columns 4 to 6. Okay, remember for columns 4 to 6 are your are your character variables. Okay, so close this, close, and then we have to have one more. Okay, all right. So we will now ask R to compute for the correlation among the numerical variables. Oops, anong mali ko dito? What's my mistake? One, open parenthesis, negative C 4 to 6, close this. Oops, there should only be one, no? 1, 2, okay. All right, so run. Okay, so let me round this because that's let's just round it to 3 decimal places. Okay, there. Okay, so we have here the correlation matrix. Okay, as discussed last time, the diagonals will be 1. Okay, since you're getting the correlation between the variable in itself. Okay, so this is the correlation between education and experience. It's negative 0.3, which means they're negatively correlated. When one variable goes up, increases in value, the other goes down. Education and experience. Okay, so we're interested in this hourly wage, and we would like that hourly wage be highly correlated with the other variables. Okay, and you can see here that hourly wage is not so much. It's not correlated to number of dependents. It's only 0.05. Its highest correlation is with education, 0.4, and its lowest is number of dependents. So as regards the correlation between your dependent variable and your independent variables, or your predictor variables, we would like them to be very high. But between your independent variables with the other independent variables, we don't want them to be high. Okay, we don't want them to have high correlation. Okay, so as far as we can see, it's only tenure and experience that have pretty high, relatively high correlation, 0.5. So tenure and experience, 0.5. And technically, we don't want that kasi we don't want that the variables will be quote unquote fighting each other in explaining your dependent variable hourly wage. Okay. So if we have perfect correlation between two independent variables, then we cannot use both of them. We will just have to choose one of them. Otherwise, we will fall into multicollinearity. Okay, so from here we can see that hourly wage is its highest correlation is with education. Ang susunod yung tenure na. Okay, so let's now try to model this. So we're now using model 2. Okay, model 2, and we're regressing hourly wage on education, experience, tenure, race, gender, plus civil status, plus number of dependents. So we have 1, 2, 3, 4, 5, 6, 7. 7 regressors, and data is equal to wage. Okay, if we run this, by the way, we can write this as Control C. Let's copy this. Control V. We can run this as, okay, so this is the same. Hourly wage regress on that means all, including all your independent variables. So that's a shortcut, okay? But personally, I prefer indicating all. Okay? All right, so let's just run this. Oops, sandali ah. Wait, class. Character. Okay, may I know, class, what happened to your regression model? Did it generate any result? Feedback, please, class. Did your model 2 return any result? Hello, class? Okay, it did, no? Surprising. Okay, the rest, nag-return ba ng result? Okay. Okay, I think R did change something here, because normally, class, or maybe a few months ago, if you run this, it will generate an error term. Why? Why will it generate an error term? I'm surprised that now it doesn't. So just last term we were using this and it generated an error term. Maybe it's because of the newest R Studio version. Maybe I'm not so sure. But tenure, race, and gender, if you recall, they're all categorical variables. Okay, and if we check, okay, that's why I did this, because I was surprised. I was expecting that it would generate an error term. If we check the class of wage, let's say gender, there. Let's check the class of that. It's character. It's character, and the older versions R and RStudio will not run this if you're regressing a variable on categorical variables. So let me just show you what, in case you meet that class, no? Okay, in case you meet that scenario, okay, let me Control Alt. I inserted another code chunk, and just in case you're working on a particular R and then it returns an error term and it gives you a message that these are categorical variables and you cannot use them for regression. What we can do is we can convert. So for example, let's let's start with race. Okay, so I'm now I'm now converting race, okay, into what we call as that factor. Okay, a character variable is a factor variable is different from a character variable. A factor can be used to classify. Okay, for example, what's a factor? A factor is a type of a character variable that's used for classification. For example, you have year level, and you have frosh, sophomore, junior, senior, etc. Those are that's a character variable. However, we can use that for classifying. Okay, so some character variables can be used for classifying. We can convert it into a factor. Okay, other variables, not all character variables could be identified as factor. For example, address. So that field contains the address of the individuals. Now, it's highly unlikely that you're going to use that as a factor. So you classify people by their address. Better if it's from, for example, city. So city, Manila, Cebu, Bohol, etc. Then that's a character variable that you can use as a factor because you can classify people according to where they reside, for example. So whenever you have a character variable that you can use as a classifier, then you can convert that into a factor. I'm just surprised because this would not have ordinarily run. Okay, ito. When we check the class of gender, it was still character. Now let me illustrate to you. Okay, so what we're doing here, let me just copy this, Control C, Control V. Okay, what I'm telling R to do is that, okay, you still have this variable race in the wage data set, but you're converting it as a factor. Okay, so let's copy this, Control C, Control V, Control V, and let's just change the others here. So we have race, and then you have gender, and then this one also. You make it this gender, and then here you have SIV status there, and here also. Okay, what are we doing now? We're converting race, gender, civil status into factors. Okay, so this was what's being done before, just a few months ago. I'm surprised why this is running. Okay, but just in case, guys, you meet, for example, a particular version of R, and you meet an error term when you're regressing character variables as independent variables, then you have to first convert it as a factor. So let's run this. All right. Now, when I look at class wage, $, see race. Okay, let's check what's now the class of race. Okay, you can see now that it's a factor already. Okay, factor na siya. Okay, so let me see. Okay, since we have converted it into a factor, okay, so let me just run this again. Okay, by the way, there's this equationmatic package. So let's kindly install that, please. Install that packages. Control C. Equationmatic. Okay, let me install that again because this is a new version of R and R Studio. And then you can refer to this site here as to what equationmatic function can do, and then let me require it library. Okay, then let's run this. Model 2, LM, hourly wage regression, education, experience, and new race, gender, civil status. And then this function, extract equation for model 2. So let's run this. Okay, I'll just run the second one. And you see here LaTeX, guys, Control C. Okay, you can see here that the, oops, my malicious experience. Dapat wala to. Yan. Okay, anyway, it's just a way to write the equation, okay, in LaTeX, okay, using the extract equation function. Okay, let me pause for a while, and then what I did was to, kasi hindi siya nagra-run dito, no? Okay, I copied this there in the script window. So I'll give you a few seconds to work on that. Just like what we did before. Okay. I inserted 2/1/ here so that it will go to the next line. Okay, any questions, class? Clear so far? Paki-chat naman please kung yes. Okay, good. Okay, I don't expect you, of course, to learn LaTeX in one sitting. It takes time, and then it also takes effort to learn how to. Because for example, for your first group quiz, okay, you'll have to write the equations. Okay, and it's so unwieldy, class, if you're going to. Uh, and the best way to generate it is using LaTeX, just like the example that we had last time. Okay, this one. Okay, you can write a text in very good format using LaTeX. Just learn the syntax a bit. Okay, it's not really that difficult to learn. Just have to follow certain rules. Okay, and as usual, the internet is awash with several examples and rules on how to do LaTeX writing in R Markdown. Okay, so let's go back to what we were discussing. So this is our equation. Hourly wage is equal to your alpha. This is your intercept plus the slope for education, beta 1, plus the slope for experience, plus beta 3. Beta 4 is the slope for your, now take note, this is raised white. I'll explain in a while what's the meaning of this raised white. And then beta 5 is, so here, something's wrong with your beta. Okay. There. Okay, I added 2 slash here so that beta will still be slash beta underscore 5 is beta underscore 5. Okay, so this is our equation. This is our regression equation. And then let me Control Alt I. Let's summarize summary. Oops. Summary mod 2. Okay, so actually it's good to give names to this. No? Sample regression mod 2. Okay, so that if you take a look at the, let's run this first. Okay, so this is the regression line. This is the regression model. Let's take a look at the output. So this is the formula that we placed. Hourly wage regress on all your variables. Data is equal to wage. Then we have some stat about the residuals, the minimum and the maximum residuals. And then you have the regression output here. Okay, so this is what you met in your previous subjects. So you have your intercept, the value is negative 3.38, and then it's statistically significant at 0.001. Okay, how do I know it's 0.001? The 3 stars here represent this one. Okay, so it's significant at the 0.1% level of significance. This one is a dot. So this one means it's significant if you're using a 10% level of significance. Okay, so this is 3, 3, 3, and the rest are not significant. Okay, so we have some information about your overall goodness of fit. Okay, F statistic at 43.54 on 7 and 518 degree of freedom. P-value is 2.2, negative 16. Okay, let's quickly interpret this. So what will be our equation? Our equation, our linear model will be hourly wage is equal to negative 3.38 or negative 3.39. Let me just round it off to the nearest second decimal place. So remember, intercept, even if it's not significant, it has to be included. It's usually, the practice is it's included in the model. And then you have 0.57 times education. And then let's not include experience. Okay. We are using a significance level of 5%. Level of significance of 5%. Okay, so this is 0.07. So we are going to reject this hypothesis that experience is not equal to 0. Is equal to, we fail to reject. No? Okay, tenure. So that's 0.14 times tenure. And then you have race white is not significant. Gender male is significant. And then civil status is not significant. Number of dependents is not significant. So you notice, class, that number of dependents, which has the lowest correlation, if you recall that, ito yung pinakamaliit na correlation with hourly wage. Turns out to be that this is not significant, no? As compared to the other predictor variables. Okay, so let's quickly take a look at the meaning of this. What's the meaning of first 0.57? Okay, the variable for education. What's the meaning of that? Anyone? Kindly please interpret 0.57, rounding it off. What did you learn in your previous subjects class? What's the meaning of 0.57? Anyone would like to volunteer to explain? What did you learn in your FINTSAR? 0.57 means no volunteer. Sige, I'll try to ask lang, no? James, Mr. Estrada, what do you think is the meaning of 0.57?
Sir, I don't know po.
Don't know? Sige. Okay, thank you, James. Any volunteer, guys? Hindi nyo po, I'm sure na-meet nyo na siya sa FINTSAR nyo, no? Okay, so first question, will 0.57, will education form part of your regression model? Yes. Okay, it's statistically significant, even at 0.001. 3 stars here. Ito yun, no? So the meaning of 0.57 is that for every, let me write that, for every 1 year. Bakit year? Kasi education in terms of year. For every 1 year increase in education, there is a corresponding 0.57, since dollars yan, no? Dollars yung currency niyan, $0.57 increase in hourly wage, okay, comma, ceteris paribus. Okay, please learn this, guys. We have to know how to interpret these values. Okay, education will form part of your model because education is statistically significant. Yung value natin na 0.57 based on the p-value, okay, this is way less than 0.001. Okay, so how do you interpret this? For every 1 year increase in education, there is a corresponding $0.57 increase in hourly wage, comma, ceteris paribus. What do you mean by ceteris paribus? Ceteris paribus means all things being equal, all things being the same. Which means that you're going to increase education, only education, by 1 year. The rest, you're not going to increase. Okay, same pa lang, same lang sila. That's what we mean by ceteris paribus. Okay, we're only changing education by 1 year. We're looking at the impact, marginal impact of education on hourly wage. Of course, if education increases by, if you increase it by 2 years, then hourly wage will increase by 0.57 times 2. Okay, so that's what we mean by marginal impact of education on hourly wage. Okay, pause muna ako guys. Clear ba yon? Clear ba yung interpretation natin? Kindly please chat if the interpretation that we gave to education is clear. Feedback please, class. Okay, thank you. Yan. Okay, good. All right, good. Thank you. All right. How about experience? Let's assume that experience is statistically significant, no? At 0.05. Kaso 0.07 siya, no? So greater than 0.05. So this will not be included in the model unless we're using a level of significance of 10%. Okay, so experience, what does this mean? So for every experience years then, no? For every 1 year increase in experience, there's a corresponding 0.02 dollars increase in hourly wage, ceteris paribus. Ganon din, no? Same. Assuming that experience is statistically significant. Okay, let's go to tenure, which is also in years. So for every 1 year increase in tenure, there's a corresponding $0.14 increase in hourly wage, ceteris paribus. Okay? Ibig sabihin, every time na nag-i-increase ka ng 1 year, yung respondents dito, tumataas yung hourly wage nila ng around 14 centavos. No? All things being the same. Ibig sabihin, ang i-increase lang natin ng isa, si tenure. The rest, hindi natin, we will not increase tenure. We will not increase the other variables. Okay? All right. Next. Itong race white na to, ano to? Bakit siya may race tapos white? Tapos isa gender male tapos civil status single. Bakit naka-attach yung ano yung mga ano, yung mga levels, no? Sandali Tingnan natin i-ano natin yung summary ni wage. Balikan natin si summary ni wage. All right. So okay, hindi siya na-identify ano. All right, ito na guys. si race, dalawang klase siya, no? Non-white 54, white 472. Okay, take note. Nung una natin ginawa sa summary, hindi naman binigay ito diba? Binigay lang yung count ni race, binigay lang yung count ni gender, binigay lang yung count ni civil status. But because we converted this into factors, okay, in-identify ni R yung levels ng factors. Okay, in-identify niya. Si non-white 54, si white 472. Si gender 252, si male 274. Si civil status 320 and married 206 single respectively. Okay, so these are the different level, we call it levels, no? Factors kasi si race, si tenure, si race at saka si race, si gender at saka si civil status. Okay. Now take a look at race. Okay. Alphabetically, sino mauuna dito? Class, alphabetically, sino mauuna? Hello, class? Alphabetically, sino mauuna? For race. Okay, non-white, no? Non-white, you're correct, alphabetically. Even if, let's take a look at Rage here, si Race, even if nauuna si white dito, no? Pero alphabetically, mauuna si non-white. Okay, so why did I ask that question? Kasi, pag factor variable, guys, ano mangyayari? Since character to, no, gagawing, idadamify ni ano to, idadamify, I'm using terms, not damify. Magkre-create si R ng dummy variable. Ano yung dummy variable? Kasi character to, di ba? Although kinonvert natin into a factor, okay, the mere fact that we're converting this into a factor, automatically ang gagawin ni R, idadamify siya. Ano yung damify? Papalitan niya to into ones or zeros. So how does R do that? Paano gagawin ni R yun? Okay, ganito gagawin ni R. Alright? So titingnan niya ano yung let's say sa civil status, no? Ano yung mauuna na alphabetically mauuna? Si married. Right? Kasi letter M siya. Si single Si single S. Therefore, ito yung gagawin niyang benchmark. No? We call it benchmark. Benchmark, sorry for the handwriting. So, what does it mean for it to be the benchmark? To be the benchmark, gagawin niyang equal to 0 yan. So, yung isa, si single, siya na yung magiging 1. Okay, therefore, to dumbify this means to convert it into a 1 or a 0. Ito magiging 1. Lahat ng married magiging 0. Single 1. Married 0. 0. 0. And 1. 1. 1. 0. Okay? So that's what automatically R will be doing. Idadamify niya yung factor. Okay? Idadamify niya yan. So this technically becomes like a numerical variable. Kasi i-convert niya yan into either 1 or 0. Okay, question. Ilang dummy variables ang gagawin ng R? You have 2 levels, no? 2 levels. Ilang dummy variables? So the number of dummy variables will be equal to the number of levels minus 1. Okay? So that's the number of dummy variables. Ulitin ko. Si civil status, ilang levels yan? 2. Married at saka single. Therefore, ilang dummy variables ang i-introduce ni R? So the number of levels, which is 2 minus 1, is equal to 1. So only one dummy variable. Okay? Isa lang. Bakit isa lang? Di ba dalawa yung levels? Kasi makaka-capture na lahat ng levels dito. Diba? 1 single, 0 married. Captured na. Lahat ng levels makaka-capture niyo dyan. Okay? Clear ba yun so far, guys? Okay, let's suppose you have a variable where there are 3 levels. 3 levels. Kunyari, let's say location. Let's just name Makati, MK na lang. Tapos Quezon City, QC. And then Manila. Yan. Suppose you have a variable where you have three characters, no? 3 character types. We have Manila, MN, Makati, and Quezon City, QC. So question, this is a character variable. But can we use this as a regressor? Pwede ba? Can we use this as a regressor, guys? Please check, please. Pwede ba natin magamit na regressor to? What's your say? Manila, Makati, Kansas City. Hello, class. Answer is pwede ba natin gamitin to? Kunyari may field tayo dito na na location. Tapos yung location niya, Manila, may Makati, may Quezon City. Can we use that? Answer is, okay, Charles, why? Could you share? Guys, pag nag-answer kayo, kindly share it to the whole class. Huwag lang sa akin. So that your classmates may benefit also from your answers. Charles, why do you think this can be used as a regressor? Pwede natin gamitin independent variable. Okay. Okay. All right, sige. Okay lang. All right. So the answer, guys, is yes. Pwede to. Pwede, we can use this as a regressor. Ibig sabihin as an independent variable. Bakit? Remember, class kapag character, kung pwede siyang gamitin na classifier to categorize the respondents, pwede. Okay. So those coming from Manila, those coming from Makati, those coming from Quezon City. So although this is a character variable, pwede to kasi it can be used as a classifier or as a category. So pwede to, no? Okay, so what we are do so una dapat gagawin natin tong as factor, no? Sorry, wait. Dali. My throat is acting up. Okay. So, yes, pwede itong gawing we can use this as a factor, as a predictor, as an independent variable. So, ang question, ang gagawin natin, i-convert natin to as a factor, di ba? What we did a while ago, so that we can use this. And then, automatically si R, ida-damify niya to. Ang tanong, ilang dummy variables ang gagawin dito? And simple lang, class. The formula is, ilang levels ba? Manila, Makati, Quezon City. So, ilang dummy variables? Correct. Thank you, James. That's correct. 2. You're correct. 2 dummy variables. Bakit? The number of levels minus 1. Bakit ganun? Bakit ganun, guys? Kasi you will be needing 2 dummy variables to capture entirely yung data natin. Okay, paano? So, what will R do? Hahanapin niya yung alphabetically mauuna, which is MK. So this will be converted into a benchmark, or in other words, isi-zero out nito. The rest will be 1 and 1. So, mag-i-introduce ng dalawang dito, dummy variables. Isa let's say, location, say, underscore, MN. Okay. And then pangalawa, location, underscore, QC. Okay. So bakit dalawa lang to, Manila at saka Quezon City? Kasi nga, isi-zero out si Makati. Okay. So you will have 2 dummy variables here. Dalawang columns to. So for example, respondent number 1 is from Manila. So 1, 0 to. Okay. Respondent number 2 is from Quezon City. So 0, 0, and 1. Respondent number 3 is from Makati. 0, 0. Diba? So lahat ng mga variable, lahat ng mga levels, maka-capture kahit dalawa lang. Okay? Even if you only have 2 dummy variables. Now, you cannot use 3 dummy variables. Magagawa ka pa ng Makati. Okay? So sobra na yung independent variables natin. You will fall in what you will be guilty of what we call a dummy variable trap. Dummy variable trap. Okay, magkakaroon tayo ng multicollinearity. Okay? So we do not include three dummy variables pag tatlo lang yung levels. No? So we only include two dummy variables kasi lahat ng scenarios, whether you're Manila, Quezon City, or Makati, nakaka-capture. Okay? So I hope this is very clear. No? In our case, yung mga yung mga dummy variables natin, dadalawa lang yung mga levels, so iisa lang yung mga output nila. Okay, so let me close this first. Balik tayo dito sa output natin. Okay, kailangan tanggalin natin kasi hindi natin nakikita yung Annotate. Let me clear first all the drawings. Okay, let's take a look at this. Now, take a look at this, no? Race at saka Y. Annotate ulit natin. Race at saka Y. Notice, class, na tinanggal niya si non-white, which is the benchmark. Okay? So, in-affix niya kay race white, which means that this is a dummy variable. Okay? Kasi race naman yung natin, di ba? Yung original na variable. Pero ginawa natin factor, tapos ginamit natin na regressor. So, pinapakita dito race white. How about gender? Gender male. Sinong tinanggal niya? Si female. No? Ginawa niyang benchmark. So yung hindi niya dimension dito, yun ang mga benchmark, yun ang is equal to 0. Civil status, single. Bakit single? Kasi si married, siya yung alphabetically nauuna. So siya yung ginawa ng benchmark. Okay, ang importante dito, how do we interpret this? Okay? Although race white is not significant, let's assume first that it is significant. No? So how will you interpret race wise? The way you interpret this is that on the average, let me write. on the average, okay, white employees receive ito, 0.11 dollars more than their non-white counterparts. Ceteris paribus. Okay, so now the interpretation is different now. Kapag factor, ini-interpret natin siya in relation to the benchmark. Sino yung benchmark natin? Yung ginawang 0. Si non-white. So how do you interpret this now? Si white daw, yung may sa race, yung mga white people on the average receive $0.11. Okay? More. Bakit more? Kasi positive to. Okay? They receive $11.11 more than their non-white counterparts, ceteris paribus. Okay, next. Ito. Si gender male. Significant to, no? Statistically significant. Okay, on the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. Okay, and lastly, assuming this is significant, on the average, okay, single employees receive $0.46 less. Less, guys, kasi negative to. Less than their married counterparts, ceteris paribus. Okay. All right. So, pause muna ako. Okay, I'll give you time. Maybe you're writing notes. Okay, and then I will ask guys kung clear so far yung pag-explain natin. If it's clear so far, paki-chat naman please. I'll appreciate that so that I know if I'm getting across well. Yes, thank you. And I hope everybody responds. If you have any questions, please feel free to ask questions. Okay, good. Clear sigurado? Clear ba yung explanation to? Clear naman, class, please? Okay? Okay, Mia, magtanong ha. Okay, we're all in this together. Okay, very good. Thank you so much. So we learned how to interpret yung mga regular na variables natin. Ibig sabihin ng regular, ano siya, yung numerical and yung factor natin. Yung factor medyo tricky ha. Okay? So if you had a while ago yung Manila, Makati, ang lalabas yan dito, location, Manila, location, Quezon City. And you would have interpreted it also in relation to Makati. Kasi si Makati yung benchmark. Right? And then si number of dependents, hindi significant. But if it was significant, ganun din. Okay? On the average, one number of dependent, ano to, tao, di ba? One person, siguro one person increase in the number of dependents will results to a $0.15 increase in hourly wage, ceteris paribus. Okay? All right. So lastly, ano yung intercept? How do we interpret this? How do you interpret this negative $3.39? Sabi natin, di ba? Lahat yung intercept, that's the value of your hourly wage, that's the average value of your hourly wage when all the parameters are, thank you, when all the parameters are zero. Okay. So, ano ibig sabihin nito? Negative 3.39 daw yung hourly wage. Of course, that has no practical meaning, no? That has no pragmatic meaning. Kasi wala namang hourly wage mo negative, ikaw pang magbabayad sa company. Hindi naman pwede yun, no? But we're just interpreting it for the purposes of interpreting it. So, how do we interpret this? On the average, a person, an employee with no education, no experience, no tenure, who is non-white, who is female, who is married, and no independents, receive on the average negative $3.39 of hourly wage. Okay, let me repeat that. Kasi sabi natin, zero dapat lahat yung mga independent variables natin. So, itong taong to, this person with zero education, zero experience, zero tenure, who is non-white, remember guys, pag zero to, diba? Pag zero to, non-white yun. Right? Kasi factor to class eh. Pag zero tong race white na to, ibig sabihin si non-white yun. Pag zero tong gender male na to, ibig sabihin si female yun. Pag zero tong civil status na single na to, ibig sabihin si married yun. Okay? So, repeat that again, guys. I'll repeat that. A person who has 0 years of education, 0 years of experience, 0 years of tenure, who is non-white, who is female, who is married, who has zero number of dependents, on the average receives negative $3.39 of hourly wage, ceteris paribus. Yun. So that's how you interpret the intercept there. Okay. All right. So, okay, I have 2 more minutes here. Okay, and then let's take a look here. Overall goodness of fit. Ano yung overall goodness of fit natin? Okay, ito yun, no? F-stat, 43.54. Okay. Ano yung overall goodness of fit? Sulat ko lang quickly, class. Overall goodness of fit is that ang null hypothesis natin dyan, HO, is that your beta 0 is equal to beta 1 is equal to beta 2 hanggang is equal to beta 7. No? Beta 7. Bakit beta 7? Kasi 7 yung regressors natin is equal to 0. So this is our null hypothesis for this overall goodness of fit. And then, okay, so what's the p-value? The p-value is this one. Okay, so our conclusion is we reject this null hypothesis. Reject natin to that beta null, which is the intercept, hanggang beta 7, the number of dependents is equal to 0. Okay, the p-value is very low, significant at 0.001. Okay, degrees of freedom sa F statistic is 7. Saan nagaling tong 7? 7 yung predictors natin. Okay, and then 518, saan nanggagaling 518? Okay, so that's the number of respondents, 526. 526 minus k minus 1. 526 minus k. K is a number of predictors, which is 7, and then minus 1 pa. Okay, minus 1. Bakit minus 1? Kasi we lose 1 degree of freedom in estimating, in estimating beta null. So beta 1 lang guys ha, yung number of predictors natin, beta 1 hanggang beta 7. Sorry, nasama ko si beta null. Si beta null kasi intercept yan, di ba? But we still subtract that from the degree of freedom kasi we lose 1 degree of freedom every time we also estimate the intercept. So that's why the degree of freedom, df1, the degree of freedom 1 is a number of parameters, 7. df2 is n minus k minus 1, so 518. N is 526 observations, minus k, which is 7 minus 1, is 518. All right? So, next meeting, guys, itutuloy natin to. We'll continue with this. Last thing, ano ibig sabihin adjusted R-squared nito? 0.3619. It means that 36% of the variability of your hourly wage of our dependent variable can be explained by your model. Okay? Tumaas to dati, last time, ilan lang no? Sa model 1 natin, ilan lang yung adjusted R-squared nun. Not even half yata. So now it became 36.19. So which means that our model is able to explain more hourly wage as compared to dun sa dati na simple linear regression model. Okay, so with that, guys, let me stop recording.